So these all are the topics that we are going to discuss today. Okay, fine. Okay, so these all are the topics that we are going to discuss today. So let's first start with the introduction to the operating system and the programming language, right? Okay. Yeah, I posted the topic name in the chat box. Okay. So now, first of all, if you want to check whether this is working or not, so you just write here, print hello, and execute this cell. So you can click on this button, and if this is working fine, so it will be giving you the output hello. Same thing will be printed. Okay. So you'll see that this Google Colab is working fine. Okay. As of now, it is giving me the output, so this is fine. Now, so let me start with the introduction to the operating system. I asked the first question, why we use OS or the operating system. Okay, so very first question and the very basic questions also. What is OS? Why do we need OS? Operating system, basically, it is a system software. It is a system software. Okay, operating system is a system software. And why do we use this? So we use it for a numerous purpose. For example, it is used to run the other application on the computing devices. Okay, it is used to run other applications on computing devices, right? So for example, if you talk about computer, if you want to run any application, for example, you want to run WhatsApp application or Paint application or Microsoft Word Office application, anything, calendar, contact, any application you want to run, you need one operating system. Why do we need an operating system? Why can't we run the application directly on our system? So let's understand that. Okay. So we know one thing. Okay. So first thing, we need to understand that whenever we start writing any program, right, or whenever you write something on your system does not understand whatever you are writing on it, right? So let's say if you write hi or hello, so it does not understand what exactly you have written. So what you need to do is you need to write this code like your system understand just the basic language or the binary language. So whatever computer you have, whether you have high-end supercomputers or normal computers or even a mobile, so these all systems, they are the combination of some hardware components, right, or some electronics component, right? Some electronic component. You have the RAM, you have the CPUs, you have the motherboard. These all are nothing but the electronic component. And these all electronic components understand only one language, that is the language of 0 and 1. That is the binary signals. Okay. So they understand only the signals. Okay. So this is 0 and this is 1. This is 0, this is 1. So high or low signals, it understand. Okay. This on Google Colab. This is not on Google Colab. This is a separate thing. This is a notes which I'm drawing. This will be getting later. Google Colab you can get. Just type Google Colab in the Google. You'll be getting it. Okay. Ignore this part. I'm just explaining on this whiteboard. You'll be getting it later. So what we have got this. What we understand from this, that our system understand only the low level programming language. So if you say hi, okay, if you say hi, so this hi you will send it to your system. Your system will convert this into the signal, and then this signal will be passed to your electronic components, and then they will be executing those signals to give you the output. right? So this is the execution sequence. If you are writing something into the human readable format, still that will be running on your system into the very low level programming language. That one common fact or one common thing we should know, and I hope everyone knows about it. Okay, even if you don't know, so I hope by now you know it, correct? So what we have seen, that if you want to run any application, that application is what? You are giving some instruction to the computer. So when you touch your keyboard, or when you, let's say, when I'm moving my cursor and I'm pressing on this, so I'm switching the tab, right? This is one instruction given to the computer, but this instruction came in the form of visual, right? So with the visual OS, I'm able to move my cursor and then I'm clicking on it, right? So we have the UI, user interface. With that, I'm able to give the instruction to the computer. At the very low level, this instruction will be going as the signals. Okay. Now, whenever you have an operating system, so operating system is what? So if you just have a hardware component, and if you'll be giving the signal, it cannot run the complex operations. Like on the computer, we do the complex operation and we run the multiple applications, right? Not only one application, we run the multiple application and we do the multitasking. So when it comes to multitasking, you can do on a computer if you have a communicating system for that, right? So operating system is nothing but a system software which helps us to communicate with the hardware or with your computer system. Okay, if you will not be having the operating system, so you will not be able to guide yourself, right? Let's say if you want to go to your start menu, or you want to go to your launch pad, or if you want to launch any application, if you want to start any application, if you want to close any application, you want to give any instruction to the computer, you need an interface for that. Okay, so this is what operating system is called, the interface. Okay, number 3 point, OS is an interface between computer and the user. Okay, between user and computer. So we are the user, this is the computer, and if you want to talk to the computer, you cannot directly talk. Okay, so what happens at the very low level, if I'll draw the picture, so at the very low level, you will be having the you guys will be having, this is called the, at very low level, you are going to have let's say this is the user. Okay, on top you have the user, then after this you are going to have, you will be having few applications, right? Now these applications will be then after this you will be having the operating system. You will be having the operating system, and this operating system then it will be running on some hardware, right? So let's say this is the hardware component. Okay, so first of all, what we have some hardware component at the very core of the computer. Then on top of that, we are having the operating system, right? Now this operating, on top of that operating system, you will be having the application. Okay, applications, and then you will be having the user at the very top. So we are at this level, and you have the hardware component. So if you want to interact with this hardware, you cannot directly interact with this hardware. You need the help of the application software and the system software. As a system software, we use the operating system. Okay, as a system software, we use the operating system. Now if you want to run this application cannot run directly on this, because let's say if you want to run 4 application, which application this hardware will be running? Application 1, application 2, application 3, or application 4? Which application it will be running? Your hardware will not be able to decide, right? So it is the task of the operating system that how and when this application will be running and which application will be running. Okay, fine. So this is the task of the OS. So other task of the OS, so first one we have seen that it works as an interface between the user and computer, and second one is the resource management and allocation. Resource management and allocation is the task of this operating system, right? So it manages the resources. These hardware components are nothing but the resources. You have RAM, you have CPU, you have IO devices, you have networking devices. These all are the different, these all are the different hardware components, or these all are the different resources. These resources has to be allocated. Let's say if your application one is running, how much memory is required, when CPU will be operating on this application, or when CPU will be operating on this application, or how much memory will be required for A2, which input device will be accessing this, like which application will be accessing the input or output device. So these all decisions, this hardware component cannot make them on their own, because if they will do that, so that the task or this whole computer system will become a complex thing to operate upon, will not be able to do that. So we need a kind of system software which can handle all those things, and that is the task operating system does. It will decide that which application to run, and which application requires how much memory, when CPU will be accessing which applications, and which IO device will or which application will access the input, output, or network components. Okay, so these all decisions are made by the operating system. Since operating system is making all these decisions, operating system becomes very important. Okay, now also whenever you are running, we have seen that whenever you want to run the application, so for those applications, the resource management and allocation is an important task that is done by the operating system. So what we can do, we can also write here, so it works as an interface. We can also write the fourth point, that OS is responsible for resource management and allocation. Okay, so this is the task of the operating system. Hope you guys have understood why do we need the operating system. Clear, everyone? Any question? Any question in this? Okay. Okay. So now let's come to the next question. So we are not going into the detail of the operating system. Obviously, this is not the class on the operating system. We are here to learn the basics of the programming, right? And remember, whatever we are going to discuss in these two classes. If you will listen to these classes properly, in future, if you are going to learn any other programming language, you guys will not face any problem, any challenge, because almost the concepts remain same. Okay, little bit changes will be there here and there, but you guys will be able to understand the basics of all the programming language. So focus clearly, make sure that certificate and everything you guys will be getting, that is secondary, but the main thing here is to learn the things, right? I'm putting a lot of effort into this. You guys are segregating 2 hours of your valuable time on weekends, so please focus on the knowledge part. You want certificate right now, I can give you the certificate, but don't run behind the certificate. If you don't have the knowledge, that is not going to help. Certificate is not going to help. Okay, if you guys want certificate, I can release the certificate right now, but that is not the agenda of this class, right? Okay, we will be giving the certificate at the end, but the main thing is focus on the knowledge part. Okay, fine. Try to gain as much as knowledge you can from these webinar session we are conducting. Okay. Okay, now let's come to the next topic, that is why we use the programming language, or what is the programming language, what is programming language, and why we use it. Okay, we'll not be discussing the operating system in detail. As I said, this is not the class on the operating system. We are just discussing the task of the operating system. And why I discuss, because there is a reason. In the upcoming class or in the upcoming session, there is some correlated things with this. Okay, so when I'll be explaining that, this part will be useful in that case. Okay, also we need to remember one more thing, one more point, that operating system OS is the first application which gets loaded into the RAM. Okay, it is the first application which gets loaded into the RAM. Now, next come to the what is programming language and why you use it. Why we use programming language? To simple the complex problem. Yes, good. So basically, to solve the problem, to give the simple solution to the complex problem, right? We use the programming language. Okay, so we'll be coming to that, but let's understand what is a programming language. So programming language is a set of predefined words that are combined into a program according to some predefined rules. Okay, so I can say programming language is a set of predefined words, that is called the keywords. Okay, keywords and or reserved words, you can say reserved words combined set of combined into a set of program. Let me write into a combined into program using a set of predefined rules. Okay, that is called the syntax. Okay, so what we understand from this definition, that programming language is what? Programming language is a set of predefined words. So two things: predefined word, that is called the keyword or reserved words. Every programming language, whether you talk about C, whether you talk about Java, whether you talk about Python, PHP, every programming language is having a set of predefined word that is called the keyword or reserved word, and every programming language has a set of predefined rules that is called the syntax. Right now, when you combine these keywords, reserved words, and syntax together, then it creates a program, and that is what the programming language is. That if you combine all of these three together, it creates a programming language. Okay, now, so why we use a programming language? That is the main question. So we use the programming language to solve our real life problems, okay, or to get our task done, to solve our problem or to get our task done. Now, if I say this, one can say that how it can do our task, how a programming language can do our task. So I'll give you an example. Let's say if you want to calculate your monthly expenses, right? Calculating monthly expenses, right? If you want to calculate your monthly expenses, what do you need? You need one application, right? What is that application? That application may be calculator. Okay, that application may be calculator. So if you have a calculator, you can calculate the things easily, right? Now, similarly, if you want to join a meeting, right? You guys need to join this meeting, so you need an application called Zoom. If you want to manage the contacts, okay, so you need the contact application, right? Contact application, right? If you want to make a call, right, on your mobile, so you need the calling application, right? You need the messenger application to communicate with the others or to message someone. You need the message application like WhatsApp, or you can say messenger, right? So these all are the kind of applications which we need to get our task done, right? Any task you want to do, you need one application for that. So different applications serve the different kind of purpose, right? One applications may be suitable for one use case, may not be suitable for the other use case. So to for every use case, we may have the application, and to develop that application, we need what? We need a programming language, right? We need one programming language. So one thing we know, that to solve our problem, to make our life easy, we need the application. But to develop that application, we need a programming language. So indirectly, what can't we say that programming languages are used to solve our problems or to get our tasks done? If you have any task, you can do the task using the programming language, not directly, but by making an application, right? You can make an application with that programming language, and then you can get your task done, right? Can I say that? Clear, everyone? Okay. Now, next, what we have? Next, we have the types of programming languages, right? So we have high level versus low level programming languages. Let's discuss this topic. So types of programming languages we'll be discussing. Types of programming languages, right? Now we have two types of programming languages. Number one, we have low level programming language. In the low level programming language, yes, Lavanya, tell me what question you have. You guys can ask it into the chat box. I will be opening up the session for the questions and answer by around 4. Okay, I'll be taking up the questions after 4. Okay, so low level programming languages. What are low level programming languages we are having? So the low level programming languages we are having is the machine language. Okay, this is also called the binary language. Okay, and we have assembly language. Okay, we have assembly language. So these all are the some low level programming languages, right? Okay, now we have some high level programming languages also. High level programming language. What are the high level programming languages we are having? C, C++, Java, Python, PHP, JavaScript. These all are some high level programming languages, right? In this low level and high level programming languages, we are learning Python, right? So the very first question is why we are learning Python, or why we are learning high level programming languages, why we are not learning low level programming language. That is the very basic question anyone should ask, right? So if I'll be coming to the question why we are learning, why we are not learning low level programming language, right? Low level programming language. So we need to understand the reason why we are not learning the low level programming language. So let's see what all the reasons we have to not to learn low level programming language. So the first one we are having here is called the user friendly, right? Number one, not user friendly. Okay, not user friendly, right? Clear? So low level programming languages are not user friendly. So if you want to have a look at what low level programming languages look like, or what binary language look like, let me show you one simple example. Sample code to add two numbers in machine language. Okay, so this is the sample code which you can see on your screen. This is the small section which you can see. This is the sample code for adding two numbers, right? These all are the instructions into the binary code. Now, if you will, you tell me that what you are able to understand. It is just a stream of zeros and ones, right? It is just a stream of zeros and ones. Probably you have some instructions here. For few people this might make some some meaning, but really speaking none of these lines will make meaning to a person who is coming from non-programming background. That will be a tedious task to write a simple code. Now I'll give you one more example that if you want to write just one line in Python, how you can do that. If you want to write just one line into the low level language, how you need to write that code. Okay. So let's say if you just want to write one single line, a is equal to 10 here. Okay. If you want to write a is equal to 10. Okay, one single line you will be writing here, a is equal to 10 into the low level programming language. How you will be writing that? So you will be using a is equal to, let's say I'm writing 97. Okay, so you have to, sorry. Let me write here 10 only. 10 only. Okay, so what we need to do to write into the low level programming language, we have to convert this a into binary, this equal to into binary, this 10 into binary. So there is something called ASCII table. I want you guys to do some research on this. So you guys can go online and you can find the ASCII table. Okay, ASCII table. This is the ASCII table where you will find every letter or every key on your keyboard is mapped to one value, right? So if you'll see this here, A is mapped to, small a is mapped to 97, equal to is mapped to is mapped to some 61 or something, right? You can find 61. This is 61. This is equal to sign, right? So equal to is mapped to 61. A is mapped to 97, right? And 10 is 1010. So if you want to write one simple code, you have to first define a table, ASCII table. In the beginning, it was not there. Let's say now it is there. So A is mapped to 97, right? Now this 97 has to be converted to binary. So how it can be converted to binary? So first 97 will be divided by 2, and you will be writing then quotient and remainder. So if you divide this, this will become 48, remainder is 1. Then divide 48 by 2, it will be 24, remainder is 0. Then divide 24 by 2, this will be 12 and remainder is 0. Divide 12 by 2, then it will be 6 and remainder is 0. Divide 6 by 2, it will be 3, remainder is 0. Then divide 3 by 2, remainder is 1 and quotient is 1, remainder is 1. Divide 1 by 2, quotient is 0 and remainder is 1. So this is the code you have, binary code for A. Now, if you will be writing equal to, let's say equal to is mapped to 61, right? Number 61. So how you can divide, how you can get the binary equivalent of equal to? So 61 divided by 2, this is going to be 30 and 1. 30 by 2, this is going to be 15 and 0. 15 by 2, it is going to be 7 and 1. 7 by 2, it is going to be 3 and 1. 3 by 2, it is going to be 1 and 1. 1 by 2, it is going to be 0 and 1. So this is the binary equivalent. This is the binary equivalent of equal to, and 10 is equivalent to 1010. So now if I have to just write one single line of code, I have to write 11000011 111101 and then 1010. You have written just one line of code, A is equal to 10 with this. Now just assume that you have to develop a Facebook application with this. How complex our life will be. Okay, no one will be able to understand, right? So this is not possible. Simply developing the complex application into the low-level programming language is not possible because they are not user-friendly. We cannot understand. We are users, right? We will not be able to understand this language. Our computer can understand, that is fine. We can do something for the computer, but for us, it should be easily understandable. Since it is not easily understandable, it is not user-friendly. So we say it is not the perfect language to write the code in, okay? Now, so one is user friendly and system friendly. So it is not user friendly, but it is system friendly. Okay, so any programming language which is system friendly or not user friendly, we can say it is the low level programming language. Okay, let's look at some other reason. So if you are going to code into the low level programming languages, we need to know the underlying architecture of the system. Architecture of system on which we are coding. Okay, so on whatever system you are coding on Mac, you are coding on Windows, you are coding on i3, i5, you need to know the architecture of this system, right? And this is not possible because every person in this system, let's say you have billions or trillions of users, right? Those who are using the computers in this world currently, right? So you cannot go and understand everyone's requirement, everyone which kind of system they are using, and then you can write the specific code for them. It is not possible, right? So when you use the low level programming language, so if I'm using Mac, so for me, you have to write a different application. Like means for the same application, you have to write the different code. If someone is using Windows, for the same application, you have to write a different code which can run on his Windows. Now in the Windows also, you have different Windows, Windows 7, Windows XP, Windows Vista. Then you have to look at the processors and all, right? Someone is using Celeron, someone is using i3, someone is using i5. So different person is using different kinds of system, and it is not going to be easy task when you change the system and you can develop the application separately for each kind of system. Okay, so this is the second reason. I hope this you understood. Need to know the underlying architecture of the system. This is second problem, right? Next problem is it is complex to learn and write the code, not manageable when program grows, right? So it is complex to learn and write and not manageable when program grows, right? So for example, in even high level programming languages also, if we code in Java or C or C++ or Python, we don't prefer to we make sure that program does not grow exponentially. Means the lines of code you are writing, that should not go beyond a specific range, because if it will go beyond 1,000, 10,000 lines of code, then the developer himself will not be able to control that application or control that program. Okay, so we will not be having any control over it. Clear? So that is going to create a problem for us. So what we're going to do is, in that case, is if we are going to write any program, or if we are writing any application, we will select a programming language which is easily manageable, and it is easily manageable when program grows. For example, if you take Python and Java, probably if one application you are developing using Java, if it is taking 10 lines of code, probably Python will take 2 or 3 lines of code, right? Python is just taking 2 or 3 lines of code. So what we can understand from this example is that if the number of lines are less, program will be manageable, right? So, and if you will see just one thing, that here you have written a is equal to 10 into the high level programming language, just to write that into the low level binary language, how much things or how many things we have written here. So just think about that, what will happen if you will develop a full program of adding two numbers, then it will be quite bulky, right? And it will not be manageable. Forget about that. Let's say if you will develop a little bit of complex application of finding the square root of the quadratic equation, that will become quite bulky, right? And it will not be able to manage. Okay, fine. So this is the third problem. Now next, let's say fourth problem. Okay, fourth problem is code is not portable. Code is not portable and not user friendly. It is complex and not to learn. Why it is complex to learn and write? Because syntaxes are not easy. Okay, fine. So code is not portable. Portable means what? So remember, there is something, some concept. There is something called source code. Okay, there is something called source code. What do you mean by source code? So source code means any code that you write. Okay, source code means the code which we write is called the source code. Is called the source code, right? So if you can move the source code from one platform to another, we can say the programming language is portable. Let's say you have written the source code. This is the source code you have written on Windows platform, or on Windows platform. Okay, if you can move this source code from Windows platform to OS platform, okay, same source code on OS platform without making any changes, this we say this programming language is portable. But in the case of low-level programming language, source code are not portable, right? Since they are not portable, so we say this programming language, low-level programming languages are not portable language. Programming languages are not portable, right? Clear? Hope you guys understood this. Okay, now. Okay, so we have understood the low-level programming languages are not portable, right? Now, next let's come to the next topic, number 5. Low-level programming languages are not expressive. Okay, are not expressive. When you say it is not expressive, what do you mean by this? Not expressive means you have to write huge lines of code just to write. If you'll see, just to write one line of code here, which programming language you will say that it is expressive? Let's say if you're writing, if you just wanted to do what? You wanted to declare a variable and assign it to a variable. It is more expressive, or this is more expressive? From which code you are getting more meaning, right? So you are getting meaning from this one, right? Correct? A is equal to 10. This one is giving you more meaningful message, right? What exactly you're trying to do here. But this is not expressive at all, right? So low-level programming languages are not expressive. Clear? Fine. Okay. So now let's start. So my next question comes here is that we are learning Python. Why we are learning Python, right? We are here to learn Python. And see, we are mainly into the data science. So in data science, Python is the most accepted language, okay? In data science and AI, Python is the best suitable language. We don't prefer to code in C, C++ or Java. What is the reason behind that? Okay, so why we are coding only in Python, why not in other programming language, that we need to understand. Next, let's come to the why Python, right? Why not other programming or other high level? We have seen that we are not going to code into the low level. Why? The reasons we have already seen. Now we are going to code into the high level, but in Python. Why Python? Why not C? Why not C++? Why not Java? Why not other programming languages, right? So let's understand the reason behind Python. I will not say the Python is the most suitable language for all the tasks or for all the applications. There are around 250 plus applications across the globe, right? There are 250 plus programming languages, right? Now, out of this, which programming language to select, how to decide, or which programming language you would prefer, how to decide, okay? So that is where we need to that is where we need to come up with some kind of formula or some kind of parameter based on which we can easily decide that how or when or which programming language to select. Okay, we need programming language for data science. Yes, we need a programming language for the data science. That's why we are learning Python. Okay. Okay. So 250 plus programming language. So the very first reason we have to identify that which programming language to select is whether it is user friendly or not. First of all, the very first thing is user friendly or not. If it will be user friendly, then it will be simple, it will be easy to learn, and it should be also expressive language. Okay, it should be expressive language. If it is user friendly, the next thing you need to check is whether it is simple or not, whether it is easy to learn or not, whether it is expressive language or not. Okay, so if these all things are fine, then you can say yes, this is the language of my choice. So if you code into the let's say you are working as a freelancer, or if you are working in an organization, or you have your own organization where you are taking the projects and you are developing the project. Someone asks that I need to develop a website, so you have the option to select Java, you have the option to select Python. You can do both. But the difference between Java and Python is you have to put extra effort in Java, whereas in Python, if you select Django package, the task will be easier and the project development time will also be less. Okay, expressive language means it should be expressive, very less lines of code you have to write, and it should be giving you the expected output, means very less lines of code is required for writing the code. Okay, so it should be able to express itself in the very less lines of code. Okay, so the first thing, it should be user friendly. What is the second point? Second point is, if a programming language, just a second, yeah, it should be maintainable. Okay, it should be maintainable. So whenever you are writing, whenever you are going to select a programming language, it should be maintainable. Okay, it should be maintainable. Maintainable means to say, so if the program grows, it is not going to break the application. Okay, or it will be easy for you to manage that application. Let's say if you are writing 10, there are a lot of situations I have seen in the industry that we keep on writing the code, keep on, like old codes are like what, old codes are having thousand, 10,000s of lines, and when we sit to debug it, like we will be lost into that. Like if any problem comes, any debugging we have to do, we'll be lost into that. Like we will not be able to find the reason where, like where exactly the error is coming from. Okay, so if you'll see Amazon program, Amazon is the Amazon application was developed into the using a functional programming language. Now it has around 10,000, 20,000 of lines of code. So one of my friend who is working at Amazon, so what he said, when he used to debug the code, so it used to take, so he used to sit overnights and then he used to debug the code. Okay, so that was a problem for him. Okay, now so see, this is why when something new things comes, right? So now if you will talk about the approach the industry is taking to develop any application is object oriented approach. So as soon as industry finds it, they try to do the transition, but transition is not going to be easy, right? Lots of people are visiting on a daily basis Amazon.com, and if you will just halt that application for one day, how much there'll be huge loss for the company, for the organization, right? So they cannot bear that much loss. So what they do, they continue with that, but yes, some small modular changes they do while at runtime. So that is different thing. But yes, when it comes to the maintainability, the code should be maintainable, right? Whatever language you are selecting, that code should be maintainable. Okay, so the next parameter based on which you have to select a programming language is number 3. It is the performance. Okay, performance. You have to take care of the performance issue. Let's say if you want a application which should not be slower, you cannot select Python. Performance wise, Python is slower than C. You need, see, data science is a kind of field. It's not like you need only programming language, you need only math. You need math also, you need programming language also, you need technical also, you need non-technical also. Okay, it is a kind of general field, right? For example, nowadays if you'll go for any organization, companies will not ask whether you have the Microsoft Office or not, whether you know about Microsoft Office or not. They are expecting you to have that understanding, right? After some time, when you go into the industry, no one will ask whether you have some basic knowledge of math or not. They will just ask, you know data science? Yes, then you have the basic knowledge of math, the one which is required for the industry. Okay, so these all things are going to be mandatory. You cannot say that, okay, so I'm not good in math, I'll not be able to do that. You will not be able to do that. You will not be able to survive into the market. As simple as that. Okay, fine. So performance is the, you can say, in case of C, performance is best for C. Okay, when compared to Java, C's performance is better than Java, right? And if you compare Python with Java, Java's performance is better than Python. Okay, fine. So performance wise, you might have a requirement that you need an application which should not be slow. Then obviously you'll not be selecting Python. Okay. Next reason we have is the specific use case. Okay, specific use case. For example, if you will talk about the if you'll talk about Python, okay, um, if you'll talk about Python, so using Python you cannot develop mobile application. So this is the specific use case, right? Specific use case is what you want to develop mobile application, you cannot develop. Okay, let's come to the performance. So performance means how fast you can run that application, a particular application. Okay. Okay, now next, let's say available libraries. Okay, so if you will be talking to the libraries, if 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 the programming language is rich into the libraries, if programming language, the particular programming language is rich into the libraries, then you can say it is going to be liked a lot. Okay, so Python, the advantage of Python is what? The biggest advantage of Python is having 200,000 plus libraries, means around 2 lakhs libraries available into the market. You go and just go to pypy.org, type anything, you will be having a library on that. Okay, and if not, then one can develop easily. If you don't have the library, you can develop it easily. Library means pre-written code to do the task. Let's say if you want to develop the calculator application, you have to write the code from scratch. Go to Python, you will find some application, or you find some library for that. Library means what? You have a good big collection of books. Library of books is what? You want to read some book, go ahead and pick that book and read that book, right? You don't have to write the book from scratch, right? Clear? Whereas when it comes to the Python libraries, it has a lot of supporting libraries. Any task you want to do, go ahead and pick the library and start writing the code. Okay. Okay. So this is the these are a few of the parameters that anyone should consider when you guys are going to select a programming language. Okay. Remember these four, 5 parameters, and you'll find that probably not on all of them, but on few of them Python supports, right? Or Python suits better. Okay, so that's why we select Python. Okay, or you can select any programming language. I cannot say that you should select only Python. If someone is comfortable in Java, go ahead and do the coding in Java, no problem. Java is also a high level programming language. If you want to come, if you are comfortable in C++, go ahead and do the coding in C++. The only thing you need to remember that when you use Python for like specific use case, I told you, for the data science, data analytics, artificial intelligence, machine learning, deep learning, NLP, these all are the fields where Python is the most acceptable programming language because of its simplicity and easy to learn, right? So this is the reason why Python is more famous. Okay, now I hope I have discussed the basic points of why we are what is the difference between high level, low level, why we are learning Python, or the Python features I will be discussing in some time. But let's discuss about these topics. Okay, these all are few again important topics. Okay, so now let's start again with source code, bytecode, and machine code. Okay, so there are 3 types of code. Mainly we say source code. Okay, so the source code is the code which we write. Code which we write is called the source code. Okay, then we have some intermediate code. this intermediate code is different in different programming languages. For example, in case of C, the intermediate code is created is called the executable code. Okay, executable code, where when you write C or C++, basically C or C++, then you have Java. In Java, you say it is the bytecode. Okay, then you have Python. In Python, it is called, sorry, in Java, it is called the object code. Right? In Python, it is called the bytecode. Okay, so these all are the different intermediate code which gets created into the different types of programming languages, right? And then what you have, machine code. What is machine code? So machine code is the low-level programming language, or the machine code is the the native code, basically I can say native code. Okay, so the native code which your system can understand easily. Okay, your computer system hardware can understand easily. We as a user will not be able to understand it easily. Okay, fine. Yes, zeros and ones finally. So I hope you guys have understood this. Now let's understand the next concept of compilers and interpreters. We'll be coming to that, but let's discuss this. So let's see how a Python program is executed on our system. Okay. Okay, so first of all, let's see in case of C what happens. You have the source code. I'm giving you the example of C, C++, C, Java, and Python. Okay, and we will see that how the program runs on these different programming languages when you write the code. So in the C, first of all, you write the source code, right? You write the source code. Let's say source code file name is abc.c. When you execute this source code, you get one intermediate code. So there will be a compiler basically. Okay, so there'll be a compiler in the case of C. This compiler will compile this source code to an intermediate code that is called bytecode. And that is called abc.exe. Now, when you this code is equivalent to native code, and when you execute this native code, it directly interacts with your hardware and gives you the output. Okay, fine. So this is the source code and bytecode. Now, this is the case of C. Now, let's see what happens in Java. In case of Java, first of all, you write the source code. Let's say this is the source code, and this code is abc.java. Okay. Now, if you will execute this, so here you will be having the compiler in case of Java, and then here you will be having the some intermediate code. Intermediate code. This intermediate code is called the abc.javac. Okay. Now, this intermediate code is called the object code in Java, remember. Okay, and this intermediate code is called the, sorry, this is not bytecode, this is executable code. Executable code in case of C. Now, here you will be having a JIT compiler. Okay, which is there in the JVM. And then it generates one native code, and finally this interacts with the hardware to give you the output. So this is the sequence of the Java. Now if you see here, we have two level of compilation, right? This is the compiler, this is also the compiler. This is normal compiler, this is JIT compiler. We'll be coming to that, what is compiler, why do we need that? But let's understand how Python program runs, okay? So let's say this is the Python code. You have abc.py. This is called the source code. You have the source code. Okay. Then you will be having a compiler here. This compiler will compile the source code to an intermediate code. This intermediate code is called the bytecode. And this bytecode is abc.pyc. Now, after compilation, there is a PVM. Okay, this PVM stands for Python virtual machine, and we say this is the interpreter. Okay, we have this interpreter. Now, when you execute this bytecode, this generates the output directly, or it converts this code into the machine code instruction, and it gives you the output. So this will be interacting with the hardware, the output, and then this will be giving you the output. Okay, fine. This is going to give you the output. So this is the execution sequence of a Python code. So what we can understand from this example, is that we have the compiler and interpreter. So everywhere we are having compiler and interpreter. So let's understand first these two things. What is compiler? What is interpreter? We need to understand these two things. Okay. So let's see this. Okay. So we know one thing. Now let's discuss on the compiler and interpreter part. Compiler and interpreter. Okay. We are discussing these two topics. So compiler and interpreter. So we know one thing that our computer understands only the low level language, right? Let's say this is the computer and it understands only the language of binary code, right? Only the binary language, correct? And PVM compiler. I'll be coming to that, wait a minute. So what we can see that every computer understands the low level programming language. So, and we write the code into the high level programming language, right? We write the code into the high level. So how this computer can understand this high level programming language? We need a translator. We need a translator. This translator are of two types. One is compiler and one is interpreter. Okay. One is compiler and one is interpreter. Hope you understand what? So first of all, let's say you take it this way, that there are two persons. One is from, let's say, India, one is from Russia. They both not understand each other's language. Like Indian does not understand Russian, Russian does not understand Indian language, right? So what they will do, if they are trying to talk to each other, they need a translator, right? That translator will translate the Indian language to the Russian language to the Russian, and then he will also translate the Russian language to the Indian language to the Indian, right? So this is a translator job. Now, this translation can be done in two ways, right? So translator can listen to person A completely and can translate to person B, and then listen to person B completely and translate to person A. Or this is called a compilation, where you listen person A completely and then translate it to B. And there is second way of translation. You listen to person A line by line and then translate it to person B. Okay. So these all are the two ways of translation. The second way is called interpretation. Okay. So now let's understand the difference between compiler and interpreter. So what compiler does, first of all, let's understand compiler. So what compiler does, wherever you will see the compiler, you will be having the source code, right? You will be having the source code. This source code, compiler takes this source code, and after compilation, it generates the intermediate code. Some intermediate code will be generated. Okay, so number one. And remember, if you have some lines of code, this compiler will take all these lines of code at once and then will compile to the intermediate code. So compiles the whole source code at once, right? Compiles whole source code at once. Okay. Number two, it generates the intermediate code, right? It generates the intermediate code. This is mandatory. This is mandatory, right? Number three, if any error comes in the source code, compilation will not happen. Let's say if the error is at this line, the whole code will not be compiled. Okay. So compilation does not happen. Compilation will not happen if there is any error in source code. Okay. Or the high level code which you are compiling. Okay. So if you have any error at any point, then it will be, yes, it is step by step execution. So then compilation will not work. I hope these 3 points are clear to everyone in the case of compilation. Any question? Compilation is clear to everyone? Okay. Okay. Now let's understand the concept of interpreter. Now, what happens in the interpreter? You write the code in some high-level programming language, right? Let's say you write some code in the high-level programming language. So, and you use an interpreter. What interpreter does? Interpreter, let's say if you have some lines of code here, so it will be taking one line of code or one instruction at a time. It will execute and gives the output for that line. Then it will be taking second line and executes, give the output for the second line. Then it will take third line for this and then executes the code and then gives you third line and so on. Okay. Remember in the case of interpreter, so number one, it executes the code line by line. It executes the code line by line, right? Or you can say instruction by instruction. This is more technical. Instruction by instruction, you should not say line by line. Instruction by instruction, this is more technical and more correct. Number two, does not generate any intermediate code. Does not generate any intermediate code. You cannot see here any intermediate code is generated. It is just giving you the output. Okay. And number three, if any error comes, in the code, it will execute the code partially. Partially means till where you are not getting the error, it will be executing the code. So if you see this, let's say if the error is at this line, so further line of code will not be executed. Line number this 4, 5, and 6 will not be executed. Only 3 lines are executed. Less 3 lines of code are not executed. Clear? So it will stop the execution. Okay. In C, we have the intermediate code, executable code. Executable code is the intermediate code. No, it is not machine level language. It is equivalent to machine level language. It is not exactly the machine level language. It is native code, equivalent to native code, which directly interact with your hardware. Okay. Clear, Akhila? Is this clear? Any question? So I hope you guys understood the concept of compiler and interpreter, right? You guys understood what is compiler and what is interpreter. Now let's come to the compiled languages versus interpreted language. Okay, very important concept. Lot of people have the doubt in this. Okay, compiled language versus interpreted language. Simple, someone will say that if a language has the compiler as the translator, then we say it is the compiled language. If a language has the interpreter as the translator, we say it is interpreted language. Python has compiler also. Why don't we say Python is a compiled language? In most of the cases, you will find that Python is an interpreted language, right? If you will read the online blogs and everything, everywhere you will find Python is an interpreted programming language. Why we not say Python is a compiled language? We have the compiler also, and I will show you that, like, you may say that no, where we have the compiler. I will show you that we have the compilation step. Okay, so if we have the compilation step, why don't we say Python is a compiled language? Okay. Okay, so let's see why we say Python is a compiled language. No, Java is also a compiled language. Okay, so 1 minute, I'll tell you how you can say which language is compiled or interpreted. Okay, so compiled language versus interpreted language. Compiled language versus interpreted language. Okay, so first of all, remember, whenever you say compiled language, or when you compare the compiled language with the interpreted language, then you need to understand one very important aspect of the programming language. It is Python is interpreted language. So one important aspect is memory allocation and type checking. Memory allocation and type checking. These two tasks you have to find that it is done at what stage. Okay. At what stage this memory allocation and type checking is done in the different programming language. Okay. Correct. So if this is done at the compilation stage, if it is done at the compilation stage, we say the language is compiled language. And if it is done at the interpretation stage, we say it is the interpreted language. Okay, compiled language and interpreted language. Okay, so these all are the two different types of programming language. Okay, so now if you will compare those who have written some code in C, C++, Java. If you guys remember, when you declare any variable, you write int a is equal to 10. You write float b is equal to 10.20. You write chr a is equal to, or chrq is equal to, let's say, a, right? You write all these things, correct? So these all are what? You specify the data types, correct? You need to specify the data type. Why? Because in case of C, when you write the source code, then you have a compiler. In case of C, in case of Java, in case of C++, you have a compiler. This generates one intermediate code. Now, when you write these all things here, so this task of this compiler is what? This compiler checks whether what the data type you have specified. If you have specified integer data type, then accordingly it will be allocating some 4 bytes of memory. If it is float data type, then it will be allocating some 8 byte of memory. If it is char data type, then it will be allocating some 1 byte of memory, right? So this is the memory allocation is done. So what it will take a memory allocation. This will be named as A, and 10 will be stored in this, right? And this will be the 4 byte of memory, right? Similarly, some memory amount will be taken. This will be float data type, B is this, and this is 10.20, correct? So what you can see, this compiler is allocating the memory, and also it is doing the type checking, what kind of type it is. Based on that, it is allocating the memory, right? Clear? Fine. So based on the data type, it is allocating the memory. So this is important, and that is the task of the compiler. C and Java compile language. Is this clear, right? What is the task of the compiler? in the other programming languages. So compiler is checking the data type. Based on the data type, it is allocating the memory. Okay, fine guys. Okay, so you have to specify the data type. If you will not specify, you will get one error here. Okay, now what happens in the Python? So in Python, this task is done at the runtime. How do you write the Python code? If you see the Python code, you don't write the data type. You just write this. Now what happens? Let's say you have the source code. Let's say this is the source code. You have a compiler here. The task of the compiler is not to check the data type, and hence memory allocation will not be done at this stage. So this will generate the bytecode based on the only one condition, where syntaxes are correct. There is no syntax error. There is no indentation error. If there is no syntax error and indentation error, bytecode will be created. And these are the compile time error. Bytecode is created. Now there is a PVM. This PVM has the interpreter. And this interpreter will now execute the code. So if you have written A is equal to 10, B is equal to 20, C is equal to A plus B. So now here you have the bytecode instruction, and this bytecode instruction will be given to the interpreter. This interpreter will allocate the memory. First, it will load the data. So when you write A is equal to 10, so first it will load 10, then it will be allocating to A. Then 20, then allocating to B, then 30, then allocating to C. So first it reads the data. Based on the data, what is the kind of data you are using, it will allocate the memory. So let's say if it is integer, so it will allocate some 28 byte of memory, and then 10 will be stored here. Let's say address is 101, so A will be pointing to this address. Remember, in this case, A is not the name of this memory address. Okay, like in C or Java, A is not the name of this memory address. Rather than that, A is pointing to this memory address, and 10 is stored into this location. Okay, so once this is done, then the you will be getting. So this interpreter will execute this, and then you will be getting the output code here. Okay, so here it will be the some output, like you'll be getting some intermediate code which will be directly running on your computer, and it will be giving you the output. Okay, fine. So this is the execution sequence of Python, and what we can see, this is done at the interpretation stage. That's why we say Python is interpreted programming language. Clear, guys? Any question till here? Okay, so what we have understood, so I hope you guys have understood the concept of compiler and interpreter, and compiled language versus interpreted language. Now let's understand the why we have the compiler. Okay, what exactly the task of the compiler, then if we have the interpreter which is doing the memory allocation and type checking, so what exactly the type of the compiler and interpreter, right? So we will be learning now about the different types of errors in Python. Okay, so let's understand the types of errors. Okay, so there are mainly two types of errors in Python. There are mainly two types of error. One is compile time error and one is runtime error. Okay, now in the compile time error, you have syntax error and you have indentation error. Whereas in the runtime error, you have name error, you have value error, type error, etc. There are numerous type of error. Okay, it is not the class where we will be discussing the error, but yes, let's understand the different types of errors. Okay, so first we will understand the syntax error and the indentation error. So let's first understand these two errors. So let's come to the types of errors. The compile time error, we have syntax error, and indentation error. Okay, next we have number two, runtime error. In the runtime error, we have name error, we have type error, we have value error, etc. Right? So let's understand these two error. For example, let's say if you will be writing a is equal to 10, what is syntax error? So syntax error is the rule which you don't follow, correct? For example, if you'll be writing a is equal to 10, b is equal to 20, c is equal to a plus b and print c. This is the simple code we have written. Execute this. Syntactically, this code is correct. There is no error in this code, so it is giving me the output 30. Very fine. No problem, no issues. But let's say what syntax says that if you will not follow the rule of the programming, what is the rule of the programming? Rule of the programming is that if you're writing print statement, not only this, there are numerous rules. How you will understand those rules, how you will remember those rules. Do you need to remember all of them? No, you don't need to remember all of them. You just need to practice the program so much that you learn all of them by practicing itself. Okay. And it is not hard. When you will write the 10 program, 20 program, by then you will come to know most of the syntax tool. Okay, so now let's say if I'll be executing this, let's say if I'll remove this bracket, this is a syntax error. Why? Because syntax says that when you write the print statement, after the print statement there should be opening and closing brackets. If you'll miss any one of the bracket, it is going to give you the error. Execute this, it is giving you the error. What error it is giving? It is giving you the syntax error. Okay, this is the syntax error. Not only this, let's say if you will see this assignment statement, we say it is the assignment statement. Assignment statement says this value should be on the right hand side and variable should be on the left hand side. If you will just change this, if you'll write 10 is equal to a, this is going to give you a syntax error again. Why? Because assignment statement says that value should be on right and variable should be on left. So you should write a is equal to 10. Okay. So this is the syntax error. Next, what we have, the indentation error, right? Let's understand the indentation error. Indentation error. So in the case of indentation error, the unnecessary spaces, if you are giving, or if wherever space is required and if you don't give the space, it gives you the indentation error. For example, a is equal to, let me write this same code. Line number indication. Which line number indication? Line 2. Oh, this one. Okay, so wherever you get the error, there you, like here, this is line 1, this is line 2, right? So that's why it is giving you the error at line number 2. Okay, fine. Okay, so let's say this is the code we have written. Execute this, code is correct. But if you will be giving unnecessary space, let's say you have given this unnecessary space, execute it, you are going to get the indentation error. Unexpected indent means unexpected space you have given here. So if your program is not expecting any space and if you give the space, that is unexpected indent, unexpected space, it is going to give you the error. Okay, now so let's understand this. Next topic. So this is the one error. Let's say if somewhere space is expected, for example, if a less than b, then if you'll see automatically it is giving some space, right? When I press enter from here, automatically it is giving the space. So it is expecting you to write the some indented code. If you will not give this space here, print a minus b, if you'll write, if you'll not give this space, this is going to again give you the indentation error, right? So what we understand from this now, if you'll be removing, if you'll be giving some space, this is fine. So what we can understand from this is that if a and b, if the space is required and if you don't give the space, then it is the indentation error. And if space is not required and if you give the space, then also it is the indentation error. Okay, and these two types of error are the compile time error. Hence, this is the reason if I told you that compile time error is there. Okay, so now if you'll see, let's say I have this error here, right? So if I'll be giving the error here, then what will happen? If I'll execute this code, so we know that if there is any compile time error, bytecode will not be compiler. So what we saw in the compiled language, that if compilation will not happen if there is any error in the source code, right? So if there is any one error in the source code, compilation will not happen. So here you have the indentation error, right? So see, the code till this line is correct, right? A is equal to 10, B is equal to 20, C is equal to A plus B, and print C. So anyway, let's discuss it here. Let's come here. What we were discussing, that if you see these 4 lines of code are correct, right? We know Python is interpreted language, so it executes the code line by line, but it is compiled language also, right? First it compiles the code, bytecode gets created, and then bytecode is interpreted, not the source code, right? Clear? If you guys remember, bytecode gets interpreted in Python, isn't it? Bytecode gets interpreted in Python, right? This bytecode, not this source code, right? So if you will see this, the code till here is correct, but it will not give you the output. Why it will not give you the output? It will not give you the output because bytecode is not created because of the syntax error, which is a compile time error. And if you have any compile time error, bytecode will not be created. We have already discussed that. If there is any compile time error, bytecode will not be created at all. So if bytecode is not created, interpretation will not happen, and it will not give you the output even for these lines of code which are correct. Execute this, you are getting the indentation error. Okay, so this is the point. Next we have the runtime error. Let's understand the runtime error and the few more types of errors. Okay, let's come to the runtime error. Runtime error. In the runtime error, we have name error, right? So let's understand. Let's say if you are writing A is equal to 10, B is equal to 20, C is equal to A plus B, print C, print A, print D, print B. Execute this. Let's see what we are getting. If you'll execute this, you will be getting the output. Okay. Now, if you will observe this, we are getting the name error. Also, if you will find this, so what is this name error? Print D, name is not defined. If you use a name in your Python program which you have not defined, it will give you the name error. And this name error is a runtime error. It is caught at the interpretation stage, right? This is the interpretation stage. What you remember in the interpretation stage, it is line by line execution. Wherever error comes, it will stop the execution there, right? So here, there is no compile time error, right? So bytecode got created. If there is no compile time error, it means bytecode got created. And if bytecode got created, then what? If you will be executing that bytecode line by line, then it stops the execution at this line. Okay, fine. This is the traceback. Okay, this is the traceback. It gives you the traceback what? That the error is at line number 7. Name D is not defined. It is giving you the traceback error. Okay, so this is the runtime error, and where, like, you will see that the code till this line is executed. Why? Because print C is 30, print A is 10. It is giving you the output. It means bytecode is created, but the error is here, so it stopped the execution here. Okay, so we understood the runtime error, we understood the compile time error. Everyone, any question in this? So we have understood the different types of error, and we have understood what is the task of the compiler. So the task of the compiler in Python, it checks for the compile time error. Compiler in Python checks for compile time error, and interpreter in Python interprets the code and checks for runtime error. Okay, so now we have discussed the how a Python program runs, source code, bytecode, machine code. We have discussed compile time versus runtime errors. We have discussed. We are left with one topic: why are we learning Python? Okay, so let's discuss few points and then I'll be wrapping up this sessions. Hope you guys have understood these all topics, the concept of compilers, interpreters, compiled languages, interpreted languages. Let me know if you guys have any question. or else I'll be discussing these things. Okay. Why are we learning Python? Or I'll be discussing Python features. But before discussing this, let me draw some conclusions here. Okay. What conclusion we have made? Conclusion number one, that if there is any compile time error, then bytecode will not be generated. Okay. Number one conclusion. Number two conclusion. Conclusion number two. If there is any compile time error, then bytecode will not be generated, right? If no compile time error, then bytecode will be generated, right? Clear? And conclusion number three. If there is any runtime error, then bytecode will be generated, but execution will be done partially, right? Clear? Bytecode, I told you, bytecode is the intermediate code in Python, Ajay. Clear? Bytecode is an intermediate code. We have just discussed it here. If you'll see this image, this is the bytecode, right? abc.pyc, this is the bytecode. Okay. After compilation, we generate the bytecode. Okay. So now let's cross verify these 3 points. We need to verify it, right? You need the proof, right? For everything we do, we need the proof for that. Let's check the proof. So what I'm going to do is I'm going to open the terminal. Remember, you guys don't have to do all these things. You just watch what I'm doing and try to understand the concept. So with this verification, try to understand that, how the things are done, how the things are running on our system. Okay, that's it. You don't have to do all these things. So you can just follow the, what I'm doing. Okay, just understand, try to understand. Now, what I'm going to do is, first of all, I'll be moving on desktop. So cd desktop. Okay, and then I will be creating a Python file, vim f1.py, f1.py. I'm using I'm using vim editor. Using vim editor, we are creating a Python file, and in this Python file, I'm going to write some code. And I will be cross verifying it. So I'll make some error. I'll check whether I'll make some compile time error. I'll show you whether some bytecode is getting created or not. So these all things we'll do. Okay, some experiment. So let's write the code. First of all, I'm going to write a is equal to 10, b is equal to 20, c is equal to a plus b, and print c. I have opened terminal and I'm doing it into the terminal. Why? Because here I can explicitly compile the file. Okay, so compilation is an implicit process. It happens automatically, and the bytecode gets generated, gets loaded into the RAM, and from there execution happens, and then that is destroyed. Like, we will not be able to see the bytecode if we will be running the file directly. I'll show you. For example, whenever you run the Python file, you can see f1.py is created on the desktop, right? Whenever I'll be running this Python file, bytecode is created, but where it is created? It is created and it is loaded into the RAM. Your CPU reads the instruction of that file from the RAM and executes it. But so if you are going to execute, what is the syntax to execute Python file from the command line? You just write python f1.py. It is executing the code. But do you see any bytecode here? No. Where bytecode will be created? There is a PyCache folder which will be created. As of now, can you see PyCache folder on my desktop? _PyCache folder. Can you see? These all are the folders. You cannot see PyCache folder. Let me compile this file and let me show you that when you compile the file and if compilation happens, it will be creating the PyCache folder. Their bytecode will be saved. So let's do this. To compile the Python file explicitly, what I'm doing, remember, I'm doing this step. I'm just compiling the Python file and I'm stopping the process here. I'm compiling the Python file and I'm stopping the process here. Since I've stopped the process here, so bytecode will be visible on my desktop. Why? Because I have saved my Python file on my desktop. So let's compile this. Python -m py_compile f1.py. Execute this. If you'll see, one PyCache folder is generated on my desktop. Just now it got generated. If you will open this, you will see that this is the f1.cpython. This is the content of the Python file. And if you'll see this file, this is generated today at 4:10 p.m. What is the syntax of the file? .pyc. And f1.cpython -38. F1 is the file name, cpython because I'm using cpython to execute the current code, and -38 shows you the version 3.8 version I'm using. .pyc is the Python compiled file. I told you bytecode is created as the .pyc file. So what we can see that .pyc file is created. Okay. So if you will follow these steps, this is the intermediate code generated. Now, if you will be executing this, it will be giving you the output. So my bytecode is generated. Why? Because there is no error in this code, right? If you want to see the content f1.py, this is the content of the file. This is the content of the file. Is there any error in this code? No. So according to our first conclusion that we made, that if there is any compile time, so second conclusion, if there is no compile time error, bytecode will be generated. So according to that conclusion, my bytecode is generated. Why? Because there is no error in the source code. So my bytecode is getting generated. Now I have to run this file. So to run this compiled file, we have to go to that folder, cd _pycache _. Okay. Okay. Now we are into the PyCache folder. Correct. We are into the PyCache folder. Let's do one thing. Let's execute this Python file. So I'll be writing Python f1.cpython -38.pyc. I'm executing the bytecode. Executing bytecode means you are executing the intermediate code and you are directly interpreting it. So it will be giving you the output. If the code is correct, it gave me the output. The code is correct. Everything is fine. So till here, the second one is cross verified. Second point, right? Okay. So we have cross verified the second point, right? Now let's see the first point. What if there is any error? Then wait, I'll give you the attendance line. If there is any error, then bytecode will not be created. If there is any error, then bytecode will not be created. As of now, the content of the Python file is what? So as here we don't have the Python file. So we need to go back, cd space _. Now if I'll check pwd, we are on the desktop, right? Now, so let me show you the content of the Python file. We have cat f1.py executed. This is the Python file. Okay. Now, what we need to do is we need to make some error into this code so that bytecode will not be generated. But for that, let me delete this PyCache folder because bytecode is saved here. So I have deleted that. Now you can see there is no PyCache folder. Let me open this vim f1.py and let me make some error here. So I'll be writing print a. I have not given that bracket. Okay, closing bracket. This is the code. Let's see the content cat f1.py. So there is a bracket which is missing, and this is a compile time error. We already have seen that. Now let's see whether bytecode is generated or not. So if bytecode is generated, PyCache folder will be generated. Let's see that. Python -m py underscore compile f1.py. You'll see that it is giving me the syntax error, line number 6 over here. So here there was a missing bracket. Since it is expecting the brackets at least to be mentioned before this print statement, that's why it is giving you the error in line number 6. Anyway, the error is there in the code, so bytecode is not generated. You can see PyCache folder is not generated. So our first conclusion is also verified that if there is any compile time error, bytecode will not be generated. Okay, fine. So now we have seen that bytecode is not generated. Why? Because there was some compile time error. Now, so first point is clarified that if you have any compile time error, bytecode will not be generated. If you have no compile time error, bytecode will be generated. That one also we have seen. Now let's see if you have any runtime error, then bytecode is generated or not. So for doing that, let's come and do the runtime error in the code. So vim f1.py. We have this vim f1.py. We will correct this. So this is fine. Now we will print D. We know that this D is not defined in this program. So this is a runtime error, right? We have already seen that, correct? Okay, now let's see the content of the f1.py. This is the content of f1.py. Now let's execute this Python file. To execute this Python file, what we will do? We will write here Python, means we are first going to compile this Python -mpy underscore compile f1.py. We are compiling the Python file. To compile the Python file, what we have, if you see PyCache folder is generated. You had the runtime error in this code, but bytecode is generated. Let's see this. If you see this now, this is the f1.c python -38.pyc. It generated today at 4:16 p.m. just now. And this is the content of the pyc file, right? Now, if I want to execute this file, so I'll be writing cd _pycache _, and now let's write this Python f1.c python -38.pyc. Execute this. You will see that it is giving me the output for first two print statement, and then it is not giving me the output for the further line. Print D is not defined. That's why it is giving me the name error, right? So we have cross-verified all the 3 points here, that if there is any runtime error, bytecode got generated, but it executes the code partially. Okay, so I have shown you that there is a compiler also and there is an interpreter also, correct? Fine, both we have in Python. Vim editor. Okay, clear everyone? So why we are learning Python? If we will discuss this point, so number one point is Python is simple, easy to learn, and expressive language, right? We have already discussed this, correct? Expressive language. Number two, Python is interpreted programming language, right? Number three, Python is free and open source. What do you mean by free and open source? Free means you don't have to purchase license. Okay. Free means you don't have to purchase the license. For example, when you go and purchase Windows, you have to purchase the license in that case, right? You have to purchase the license in the case of Windows. In Java also, if you want to use Enterprise Edition, you have to purchase the license. Python is free of cost, whether it is individual or whether it is Enterprise Edition. You can use it free of cost. And open source means source code. Python is also a program, right? So source code for Python is available at free of cost. Whereas you will not find the source code of Windows, you will not find the source code of Java. They are not open source. Okay. So this is one advantage. Number four, Python is portable and platform independent. Okay. Python is portable and platform independent. Okay. Yes, just like Android. Fine. No, in all languages, you will not find compiler and interpreter both. Okay, not on all languages, very few languages. Shreya. Okay, so Python is portable and platform independent both. I'll be discussing this point tomorrow. Okay, so this is one point, and there are a few more points we will be discussing, like Python is general purpose programming language. Bye everyone. Thank you guys. Thanks for joining. Bye.